For my video, I decided to work on the different seeking intersecting lines. So I have when they intersect on the outside, when we have two secant lines that intersect on the circle, and then two secant lines that intersect inside the circle. I think that if I were to do this with my students, that first I would just kind of give them the circle with different angles involved, asking them to try and discover, can you figure out any relationships, and see if our students can figure out the different relationships such that this angle 1 here is half of this arc here as it's an inscribed angle, or that this angle 2 here is half of this angle here as it's inscribed. And so I'd want my students to try and figure that part out on their own, to try and discover that and see that. But afterwards, I think this is what I would show my students, just to show them the different proofs. So for the first one, here we have this angle 1, and no matter where we move it, and no matter where we move the different parts of it, the students can see on the right over there that as the arc changes, or as the angle changes, the arc is as the same. And so we can see that different size. And just seeing that when we move the different things, the students can see here that all the different relationships are holding true, and that here this is our formula of what we thought it was, and this is what it's actually measuring to be. And so the students can see that these are the same here, same as for angle 2. They can see that it's the same here. And then when they start to get into realizing that we have a triangle here, and that since angle 1 is an alternate exterior angle, we can see that angle 1 is equal to the sum of 2 and x. And so since we have that, we can find our other proof. And here the students can see that the measurements of angle x are the same based off of angle 1 and 2. And then down here as well, showing the students, well, since we know what angle 1 is based off of this arc, and what we know angle 2 is based off of this arc here, we can find angle x. And so by moving it in any different direction, the values always stay the same. And we can move any of the points and change any of the chords, and even if we can't see the intersection anymore, the values will always still be equal. And so the students can see, playing with different things, that what they just proved was still equal. And then looking at it intersection when it's on the circle, with this one, asking the students, well, where have you seen this before? And so instead of having the students try and find different stuff that they know, asking them, well, what does this look like? What have we seen before that looks like this? And the fact that we just covered inscribed angles, and seeing, well, if we know this is an inscribed angle, then this angle is half of this arc length. And so the students would be able to see that no matter where we moved the different chords, and then we could even move these points here to change this chord, no matter where we move that, half of this arc length here will always be the angle. And so I would show this to my students after they had done the different proofs by themselves and seen the different formulas and where that came from. Finally, we have the inside circle, and so I once again would have them try and figure it out. What do you know? You have your vertical angles here. Where could we figure out where we have different inscribed angles to use those arc lengths? And so once they saw this first angle here, angle 1, that it's half this arc length AB. Or this arc length, or excuse me, this angle 2 here is half of this arc length. And so they would discover these two, and here they see that half of AB is the same as measure 1, and half of DC is the angle of measure 2. And no matter where we move these, those will always stay the same. We can move anything all over, and those will always stay equal. We can move this chord, move this one over here, and that they'll always stay equal. And then go back to the whole idea of the triangle. And so x is the alternate exterior of the triangle right here, and so the measure of angle x is equal to 1 and 2. And once again, moving different values and seeing that they do stay the same. And then finally to the last one here, showing that since we know these two different parts, with substitution we can see that the measure of angle x is actually half the measure of half of the measure of the arc AB and half of the measure of the arc CD. And then using the backwards to straighter property, we can simplify that. And just showing them how their proof makes sense after they did the discovery learning activity and saw how they could find the different angles, and just to since they found the proof and they now know what the formulas are, more of understanding, well, why, and double checking that it'll always work no matter what. Because I think a lot of times with math, we always wonder, well, what if we do this? Will it still be the same? And no matter what we do with these different, now we went outside, no matter what we do with these different points or chords, or where we move different things, as long as the intersecting chords are on the inside of the circle, this will always hold, and we'll always be able to find different values and see that they're always still the same.